We want to find the limit of the rational function as x approaches 5. If the limit does exist, the function must be approaching the same function value from the left and right of x equals 5. If the function is continuous at and around positive 5, we can determine the limit by performing direct substitution. In this case, though, if we substitute 5 for x, we get the indeterminate form of 0 divided by 0. This does not indicate the limit does not exist. It indicates we need to perform an algebraic technique to then hopefully determine the limit by performing direct substitution. Once we do this, we'll also verify the limit by looking at a graph as well as a table of values. In this case, because the numerator is the square root of the quantity 3x plus 34 minus 7, we will rationalize the numerator by multiplying the numerator and denominator by the conjugate of the numerator. So let's begin by writing the original function. And now we will multiply the numerator and denominator by the conjugate of the numerator, which is the square root of the quantity 3x plus 34 plus 7. Starting in the numerator, we have the square root of the quantity 3x plus 34 times itself, which simplifies to just 3x plus 34. Next, because we are multiplying conjugates, the next two products will be opposites and sum to 0. We have the square root of the quantity 3x plus 34 times positive 7 plus negative 7 times the square root of the quantity 3x plus 34. Those two products sum to 0. And then we have negative 7 times positive 7, which is negative 49, giving us minus 49. And now for the denominator, let's go ahead and factor x squared minus 8x plus 15. The factors of positive 15 that add to negative 8 are negative 3 and negative 5, giving us factors of x minus 3 and x minus 5. And we still have times the quantity, the square root of the quantity 3x plus 34 plus 7. And now let's simplify the numerator. 34 minus 49 is 15. This simplifies to 3x minus 15. Let's go ahead and factor out the common factor of 3, which gives us 3 times the quantity x minus 5 over the same denominator. Notice in this form we have a common factor of x minus 5 between the numerator and denominator. By simplifying out this common factor, we're removing the whole in the original function at x equals 5. So now the simplified function will be continuous at and around positive 5, and we can use this simplified function to evaluate the original limit. The simplified expression is now 3 divided by the product of x minus 3 and the square root of the quantity 3x plus 34 plus 7, which means the original limit is equal to the limit of the simplified expression as x approaches 5. And again, because this function is continuous at and around positive 5, we can evaluate the limit now by performing direct substitution. Substituting 5 for x, we have 3 divided by the product of 5 minus 3 and the square root of the quantity 3 times 5 plus 34 plus 7. Simplifying, we have 3 divided by, well, 5 minus 3 is 2. And then under the square root, we have 15 plus 34, which is 49. The square root of 49 is 7. 7 plus 7 is 14. The denominator simplifies to 2 times 14, which is equal to 3/28. So this indicates that the original function approaches the function value of 3/28 as we approach 5 from the left and the right. Let's verify this by looking at a graph as well as a table of values. Looking at the graph of the original function, most software is not going to show holes in a function. The original function does have a hole at x equals 5, which would be here. But remember, this does not affect the limit. We're only concerned about what function value we're approaching as we approach 5 from the left and the right. So we can see from the graph as we approach 5 from the left and from the right, we are approaching the same function value that is between 0 and 1, much closer to 0, which actually is 3/28. And now looking at the table of values, as we approach 5 from values less than 5, we can see the decimal value we are approaching. And if we approach x equals 5 from values greater than 5, again, it does appear we are approaching the same function value in decimal form. So let's just verify that 3/28 is approximately this decimal. Notice 3/28 is a decimal value we are approaching from the left and right of +5, verifying our limit. I hope you found this helpful.